This is my presentation on problem number 7, burning glass. The problem states, propose and test various methods to start a fire with magnifying glass. I'm defining fire as combustion. Here is a demonstration of me starting a fire. I have a lens focusing the flames to a point on some paper in a bowl. I also have the paper folded, but there are many layers. I did this because it makes the temperature of the paper higher because it's containing the heat energy in between the layers. Doing this means it reaches its combustion temperature faster. Now note, the paper doesn't start burning straight away. That's because fire needs 3 things to combust: heat, oxygen, and fuel. In the case of starting a fire with a lens focuses the light and increases the temperature of the fuel, which is the paper. Put this in an oxygen environment, and with enough heat, you have combustion. A lens is a piece of glass or other transparent material with curved sides for concentrating or dispersing light. That means that lenses normally range from by convex to by concave. But in order to be a magnifying glass, there needs to be converging lenses. These lenses focus the light entering them to a point. The way lenses work is when light goes into the glass, it slows down. Different materials slow light by different amounts. The number that represents this is called the index of refraction. Here is a ray diagram of a lens. So light enters the glass, which is a high index of refraction, and it slows down as it bends inwards. When it leaves the glass, it speeds up, and because of the curvature of the glass, the light again bends inwards. Since temperature is the average kinetic energy of a system, and since when an electron absorbs a photon, it gains its energy, when some material absorbs a bunch of light, it gains some energy, which is made into heat, increasing the temperature. Here's a video from a thermal camera. I'm holding some paper and I'm heating it up with a lens. The max temperature is shown by the number on the top of the scale. This then leads to a graph of temperature over time. What this is showing is that the paper is heating up because the light is focused by the lens. The combustion of the paper started about here at 219 degrees. This matches with previously given values from the internet. As you see, it took some time before the paper got to the right temperature. That time is given by an equation called the auto-ignition equation. What this equation does is it tells you how long it will take for enough energy to be absorbed by the material such that it combusts without an ignition source. Here we have how heat interacts with the material through K, rho, and C. Then we have a difference of temperatures, and finally goes Q prime prime. This is the heat flux, or the heat energy input per second per square metre. In this equation, there are 2 main parts. The part that deals with the relevant properties of the material, and the part that deals with the energy entering the system. Now initially I thought that paper would be the best option, mostly because all the videos I'd seen used paper. So to test this, I tried spark fires with black napkins, black crepe paper, white printing paper, wood, grass bark, and a wick and methylated spirits. Of all these, all but the wick combusted. The reason that at certain times of the day there is least light intensity is because at dawn and dusk the sunlight is travelling through more atmosphere to get to you. Noon is the best because that's when the sunlight travels through the least amount of atmosphere. So some of the tests I did was to determine the relationship of area of effect and temperature. My setup for these tests had a projector focusing its light onto some paper to some area. This then controlled the amount of light being focused, and the only thing being changed was the area of the focused light. By varying the distance of the projector, I could change the area of the illuminated paper, but for that, change the light intensity. To get the temperature, I used a handheld thermometer and I recorded the temperature after 2.5 minutes. Here are the results. As you decrease the area of effect, the temperature increases following an inverse relationship. Also shown here is the data to back up my claim that many layers of paper is better than one. You can see that in the 8 layers of paper data, and it consistently has a higher temperature than the 1 layer of paper data. So there's some different methods that I tried which did start combustion. One of my methods was to have a tube to hold the lens steady and a slot so the position of the paper was consistent. There was also a scope to make sure contraption was facing the sun. One other idea I had was to have a glass jar that had a controllable airflow so I could control the amount of air, and the fuel, and the heat, which is all the requirements for a fire. Some other methods I tried was just a bowl to hold the paper, and the other was a gauze mat to act as support for the paper. All of them lead to the paper reaches combustion temperature. Of all of them though, the cinder beam was the most consistent, and so in order to find the relationship of lens size and time to combustion, I used the same reasoning that led to the cinder beam. The idea behind this is that the fuel is held in place relative to the lens, so it's consistently at the focal point of the lens. The lens in this setup is a Fresnel lens. The reason for this is that a flat lens makes it very easy to vary the size, the effective size of the lens. To vary the size, all I had to do was cover different amounts of the paper, and this then led to the graph here. So for this test, I had multiple areas cut out of some paper sheets to act as a variable cover. I faced the lens parallel to the sun's rays, and I also stopped timing after 1 minute and marked those tests as read. What this data shows us is that there is an inverse relationship where as you decrease the area of the lens, the time to combustion increases. Also, as you decrease the area of the lens, the variation in the time data increases, and this is quite interesting. So here we have the auto-ignition equation I showed before, and if we look at this equation, we can see that it is possible to use this to predict time based off area of lens. And what this will then become is a predictive model for the test I just showed. How this equation can vary based off lens size is because the heat flux value is given by the effect of the magnification of the lens times the solar insolation. And the magnification factor varies based off the area of the lens. So insolation is the energy input per square metre per second, and its units given is this. And as I have stated, the time of day has an effect on how much sunlight you get. This is normally given as a 30% loss per 1 AM. AM is the thickness of the atmosphere which the sunlight is travelling through, and it varies based off the time of day. And so the relationship for that is given as this. And the insolation before the atmosphere's effect is called the solar constant. So we're using this as a counting value for my heat flux. Here's the model after I put in my values. The predictions are plotted in blue and the data is shown in orange. So the model is not identical, but it is to be expected, and the model does seem to predict the right kind of relationship. But how can I reduce the differences? So how I could do this is by accounting for more factors that have an effect. Before I go into improving the model, we need to first visualise what the model is doing. What the model is doing is it's using the rate of energy input and outputting time for when the material will be at the required temperature. And so one problem with this is that the line points off to infinity. So for any energy input, eventually you will gather enough energy to start combustion, but we don't see that in the real world. We don't see that because the hotter material gets, the faster the energy convects into the surrounding air, and then the heat energy is lost to the environment. What this then looks like is this. What this means is that any loss to energy entering the system will make the time taken longer. And one of the other big factors that has this effect is the albedo of the material. Albedo is a dimensionless value that gives the percentage of light reflected. 0 is when all the energy is absorbed and 1 is when it's all reflected. The albedo value also accounts for colour. Different colours absorb different amounts of energy and so different albedo. And so albedo affects the gradient of the line and makes it smaller. Therefore it takes more time to reach the combustion temperature. And so of these effects, the albedo is the easiest to integrate into the model as it's only changing the gradient of the line, which then looks like this. So we can see that by accounting for albedo, we have increased the accuracy of the model by a lot. And so this is how the albedo is mathematically expressed. It has an effect on the heat flux. In conclusion, I've proposed various ways to start a fire. I've tested major factors in producing a flame. I've explained in theory other factors to producing a fire. I've also developed a predictive model that predicts time and used it to give close estimations of actual data that I've collected.
Very helpful. Thank you.
My name is Andrej, and today I'll be posing the problem number 12, burn glass. So the problem states that
Just keep on going, just stop.
So the problem states that to test various methods to start a fire and to test different ways to have it with a magnifying glass.
Just speak.
Speak.
Okay, so so in his theory, he talked about the final triangle and how that heat, oxygen, and fuel are needed to start a fire using blends. And he also defined different types of blends, and he describes his effect and how it will actually get to heat up the paper. And he showed that the different times of day would definitely affect his results because the angle of the rays from the sun would be different. And as for the cons, he didn't explain actually the combustion of the paper. He also, I also asked him about the fact that he held the lens with his hand, and he that makes it a human error. So he didn't have like a stand that would hold it. He also didn't even, crucially, didn't even define what a fire is. So it could be when smoke appeared, when fire appeared, and all. Also, he didn't provide us with any hypotheses or predictions for his model, and the aborted parameter of humidity wasn't measured. So in the experiment, he showed the influence of area on the temperature. He also, but as for the cons, he didn't really explain what the center beam was. He didn't talk a lot about the size of lens that he used, and the fact that he used a bowl which actually reflects sunlight. So he didn't define the exact difference that he used between materials, and he didn't measure the RGB components of paper and the chemical components that are found in that. So he didn't even measure the material temperature change, and not even light intensity. And because it's very important, it changed drastically during his experiment. As for his results, he visualized the mount rate, and he improved it later and showed it in his results. And the results provide a comparison between theory and the experiment that he mentioned. But as for the cons, he tried different methods, but didn't show us really the results for it. And there wasn't really an actual change for the method between all these methods. As for that would be all for my opposition. Now I would like to move to the discussion.
Before that, let's thank that.
That day. So, for example, you measured the air temperature always, but you didn't measure your humidity. Why not?
Well, I don't see what effect humidity would have. Maybe it will scatter more for light, it will get light intensity. Do you think that's the only...
yes, well, the thing with humidity is because that's like the quantity of scattered particles of water in air, and they could reflect the light, but they will also slow down the process of trying to burn the paper, because you can't really start paper you can't really start a fire if you have water around it. So I think that would definitely affect the time you needed to start a fire on paper.
Right, so do you think that because you've got some water in the air around, that's going to have a sizable effect on whether you can get fire or not?
It doesn't mean that it has to be really, really noticeable, but it definitely will exist. That is my stand on this. It definitely will exist. As for other components, did you measure the wind speed? I mean, when did you conduct your experiment? During really windy days or non-windy days?
Right, so I conducted the data I showed you for the area effects, the area of the lens and time to combustion. That was all done on a sunny, clear day, there was no wind. And I get your point about the effects of wind and why they would cool down your material, so then you'd get a less heat going into the material, so heat up slower, therefore a longer combustion time. The thing is though, that would be, so I explained that effect through my, when I talk about
that's all I have for this question. And so for the Fresnel lens, could you really explain to me how did you construct it, and why does it differ from the other lens? Why does the Fresnel lens really have different results?
Right, of course, yes. So, if I look at my notes, this here is an image of a Fresnel lens.
Mm-hmm.
So, essentially what it's doing is, on the jagged side, the glass is curved, so that when the light hits it refracts, exits the glass, refracts, and so because of the curvature of that lens it focuses in, it's in essence...
Okay, so basically you think that the shape is the thing that affects it, right?
Well, it's just that it's a lens, but it's flat.
Okay, alright, so also shape and the thickness. That's great. And so where exactly did you put your paper in according to the focal length of the lens?
Right, so for the lens, I found focal length with like my hand.
Okay.
Then, golly well, I have some plastic containers that have that same length. And so I...
Where did you put it? I mean, where according to...
was placed at the filter.
Okay, well, did you try maybe putting it aside from that, like closer to the lens and farther from the lens?
Yeah, so I did test looking at that effect with my projector, and I varied the distance to the projector, and that showed the effect of changing that.
Okay. So yeah, so definitely. So the conclusion is that it will take the least time at the focal length, right? Okay.
Yep, that's correct.
Okay. So. You always used your white paper for having... No, so when you mentioned albedo later in the presentation, you talked about how different materials can have different things. Okay, so how does actually lighting the fire depend on like the color of the material?
Right, so different colours. So the colour of an object is the frequency of light that the material is not absorbing. It gets reflected off, it goes into your eyes. So that's the colour you see. That means that materials of different colours are reflecting different wavelengths of light. And different wavelengths of light have different amounts of energy. So if you change the colour of the material, or if you have different colours, it's not absorbing the same amount of energy.
Okay, but so when you change the different colors, maybe you're changing like ink, so we change the chemical composition. Do you think that that may have an effect on your results?
I think it's not necessarily just ink. That is one way of changing the colour, but it's not the only way. And so there's that. Also, the ink itself would reach that temperature at the paper combust at 219 degrees. And once the ink itself got to that temperature, it's...
Okay, yeah.
Okay, we're out of time. Thank you for your discussion. Use the microphone.
Yeah, what would you propose as an additional method? Because you said he didn't test multiple ones.
Varying the actual type of lens that he used. Maybe he should have differed the thickness and the size of the thickness of the lens, and maybe the shape that it is curvature.
So the kind of lens.
Yes.
Yes. Okay. For the reporter, you talked about the focal point. Are you sure that it's an actual point, or?
Right. So of course, in a lens, it's not perfect, and so you would see chromatic aberration. That's just the frequency of light, and also I can't remember the term right now, but it doesn't focus all the way to a mathematical point. There's a disconnect.
Did you regard that the fact that when you took it, there was also an initial air temperature for your model?
Yes, and so that's why I measured the atmospheric, the environmental temperature, and I stated that that was the temperature of the paper, the initial temperature.
Did you have conclusive data for other methods that you said that you tested, or?
So, yeah, I mean, conclusive that they all got the paper to the combustion temperature and the paper combusted. And there were various reasons for why that happened.
And did you actually, what did you define as the start and when you considered fire appearing?
Right, so that is a good question. So, in my contraption, the lens, the Fresnel lens I use, could focus the light to a minimum area, let's say at a radius of about 2 millimeters, diameter of 2 millimeters. And so, when all of that directly illuminated paper had combusted, that was when I said that's combustion.
And do you know what the combustion temperature of paper was that you used?
Sorry, we're
Out of time. Questions? Thank you for the questions.
The opponent asked how you did effective heat. The reporter said he didn't see it having an effect on light scattering. For the effective heat that the opponent reports, yes. How would that surroundings change this? The report answered was unclear for the focal points. He talked about how it was measured. The other one said he measured it, indicating it with his hand. So, for strengths and weaknesses of the reporter and the opponent, the reporter seems to be reading off of his theory slides. He didn't have the best time management. He had some unplanned recognition systems. He had good interpretation. He had really good videos. The opponent had some technicality issues, introducing new materials which was unrelated to the task and but he did bring up some interesting errors. And
Thank you very much for your review.